Hello, I'm here to present the week three project CE5700 scalar vector and tensor fields. Here I have taken a umbrella for the umbrella as my figure, and I have drawn the scalar vector and the tensor field according to how an umbrella is deformed in a storm. This is the figure of an umbrella deforming in a storm. Here you can see that the force when acts on an umbrella from a direction, the umbrella deforms in the other direction and the topward, like you can see at an angle. This is what I have uh, tried to show in my figure. And you can see that the maximum force acting is on the like outmost point at the umbrella, and the shaft has also a small deflection. So let's see how I have depicted this in my scalar vector and tensor field. This is my scalar field. I have using the parameterization x1 square plus x2 square. I have given it as because I need the maximum scalar value uh, at the outmost point on the growth path or the canopy of the umbrella. So you can see that the maximum force, the maximum value of the scalar field is in the outermost position where the maximum force of the wind acts on the umbrella as I have shown you in the previous slide. This is the MATLAB code for the scalar field. Okay, and this is the vector field. And the parameterization I use for the vector field are these, and you can see that in the vector field, the maximum force is in the upward and to the right point. So you can see that if when a wind from the left side acts on the umbrella, there's the force on the each point on the umbrella is to the right and to the up. So it's an angle to the northeast direction. You can see that the force of a vector field on the umbrella is to the direction, and we can see on the vector field displacement is that when as we've seen in the image, in this image the canopy has moved, and it's moved in this part, and there is a small deflection in the shaft. As similarly you can see there's a small deflection and the canopy movement. There will be a little, the canopy will flip upside down, but I was not able to do it, but I have shown that there's a deflection in the canopy, and there's a vector field acting on the canopy. And this is the MATLAB code for my vector displacement. And I have used tensor field as the symmetric tensor as 2x1 square, 2x2 square, and x3. And this is my tensor field. And you can see that the maximum tensor value is on the canopy part, which is usually when wind acts on an umbrella. So in the four figures of the scalar field, tensor field, vector, and vector displacement, I have shown that the maximum force of an umbrella when a wind acts is on the canopy part. And this I have verified my MATLAB values hand calculation. I took a point at 888, which is the outmost point at here. This is an 8 unit height and 8 unit of radius. So cornermost point at here. So I have taken 888 and I got the value of 888 is substituted in x1, x2, and x3 of u. And I got x1 is equal to 0.609, x2 is equal to minus 0.609, and x3 is equal to 2.4, and of t is equal to 2x1 square, 2x2 square, and x3. And I have given 8, 8, and 8, and I got 128, 128, and 64. And multiplying t with u, I'm getting TU as 77.94 minus 77.94 and 153.6. And the value given by MATLAB is the body volume at 0.888, the vector u at 0.888, and tensor at 0.888, and TU is equal to 77.9474, 79.9474, and 153.600. This is the same value I have got from my hand calculation, so that I have verified my result.